All right, in problem number 11, if you were to plot these, say the point 1, -2, the point -5, 4, and the point 5, 2. All right, so if you looked at these pieces, again, this is just a sketch, so it's not a guarantee. It's hard to tell exactly what it looks like, but it is possible this is a right triangle. If you're looking to find the sides, easiest thing to do to find the sides is to just use the distance equation that you've entered in your calculator already and just type in the coordinates. So really quickly, if we were to find the sides, go to our distance formula and type in the coordinates. So A is the point 1, -2. B is the point -5, 4. Okay, so here is my distance AB is 6√2. Do the same thing for BC. Okay. In this, I already have my points -5, 4. So if I just replace 5, 2 and -5, 4, that gives me my distance BC, which is 2√26. And then finally CA, I already have my 5, 2 in here, so replace the coordinates -5, 4 with the coordinates 1 and -2. Enter. I get 4√2. So here are my distances. If I was actually going for the classifications here based on sides, are there any equal sides here? No. So I'm looking at a scalene triangle. Right? And then what if I was classifying by angles? Right, so the question asks you to classify by angles. If I classified by angles, I need to compare the sum of the squares of the smaller two sides to the square of the longer side and see whether it's acute, obtuse, or right. Right. If I were to do that, can I tell right away which is my smallest side here? Do you guys know how to do square roots? Probably not as easily. So what we can do to simplify that is just move everything inside the radical. So if I move this 6 inside the radical, what does it become? The square root of what is 6? 36 times 2 is 72. What if I move the 2 inside here? 2 becomes a 4, square root of 4. So 4 times 26 is 104. And what if I move my 4 inside here? 16. 16 times 2 is 32. So now we're able to see which ones are the longest side, and we can compare. This also makes it really easy to compare the squares of these two smaller sides. So root 32 squared plus root 72 squared, compare that to root 104 squared. The radical and the power cancel in each of these cases. So we're looking at 104 compared to 104. So they're equal. So what kind of a triangle are we dealing with? The Pythagorean theorem applies, so it's a right triangle. So we know that this is a right angle right here. And so if you wanted to find your angles, well, right away we see that angle A is 90 degrees. And then you could use trig ratios to find one of the other angles. So let's say we wanted to find angle B. And you can, since we have all of the sides, you can use any trig ratio that you want. So let's say we use B, opposite, and hypotenuse. Well, opposite and hypotenuse is sine. So we know that the sine of B is equal to the opposite side, which was AC, 4√2, over the hypotenuse, which was BC, 2√26. And so what we can do here is find the angle by taking the inverse sine of that ratio. So if I were to calculate this, I can simply take inverse sine of my ratio 4 square root 2 divided by 2 square root 26. I want to solve this in decimal form, so I'm going to hit the green diamond button since none of my actual entries have a decimal point. Oops. On this, I need to put my whole denominator in parentheses. Okay, and once again, hit green diamond, and I get 33.7 approximately for this angle. And what's the relationship between angles B and C? Acute angles of a right triangle add up to 90 degrees. So if I subtract 90 from that angle measure I just found, I get 56.3 approximately for angle C in this case. I don't remember what I asked you to round it to. No. If you solved using law of cosines, it should, if you're using these same measures, these lengths, you should still be able to solve it from that. Any other questions from the 5.4 homework, Liz?